Alrighty, folks. So welcome back. I know you guys missed me over spring break. Normally, today we will be doing a lab, the production of calcium carbonate. But we've also normally have not had Unit 7 split by spring break. So I think a lot of guys have a lot of folks have some rust to shake off. So what we're going to do is we're going to do some review of molarity calculations, of mass-to-mass calculations, of problems that kind of combine both pure substances and solutions. Sort of get the rust to shake off the rust, if you will, from spring break and make sure we are ready to cook for lab tomorrow. So these first two problems are good combos. The very first one asks you about how many more molecules or which one has more molecules of KBr? A solid chunk of 274.89 grams, or a bottle of that's 575 milliliters of a 4.1 molar solution. Which one has more KBr molecules? Okay, well, we can't compare these two directly. We got to give them apples to apples. So we're going to find the moles of both. So on the left here, the moles of a pure substance we know are the mass over the formula weight, which will apply to the solid chunk. So we're going to take the 274.89 grams, divide that by our formula weight, which in this case, a K is 39, Br is 80, so the formula weight is 119. If we do this math right here, we'll find that we have 2.31 moles of KBr in this solid chunk. Now, over here, capital M, remember that doesn't stand for moles or mass or anything like that. It stands for molarity, which is the ratio of moles per volume in liters of a solution. So before we even get into those calculations, though, this is milliliters right here. Be careful of that. Let's go ahead and convert that into our liters so we don't give ourselves a chance to make a mistake later. So molarity equals moles over volume. Well, let's rearrange this equation so we can solve for moles. If I multiply both these sides by the volume in liters, like so, my volumes will cancel out. And so if I multiply my volume times my molarity, that should tell me how many moles of KBr we're working with. Well, that would be my 0.575 times my molarity, which is 4.1 according to this problem. If we plug that in, we will find that we have 2.36 moles of KBr in this solution. So which one of these has more molecules? Well, that would be this guy right here. Another way to think of this is that whoever made this solution must have dissolved a little bit more than 274.89 grams of solid KBr in it to make it. And that's why this solution has more molecules than the chunk of KBr all by itself. Let's go ahead and take a look at number 2. So the very first thing we want to make sure we do, we're looking at a full chemical reaction at this point, is we want to make sure this whole thing is balanced. So I have two H's on the left and the right. I got one Cl, one Na, and one O. Okay, seems like I'm in good shape. It's balanced. Nice. We always want to double check that before we start a problem, so don't forget that. I'm also noticing that I have milliliters listed here. I'm going to go ahead and just convert those into liters before I even get to calculations. No sense in giving myself an opportunity to make a mistake later. Okay, so this problem says we have a certain amount of HCl, and we know its molarity. And we're told it's neutralized with 0.1963 liters of the NaOH. What must the molarity of the NaOH be? Well, if we think about this, molarity, if you recall from the last problem, is equal to the moles divided by the volume of any given solution. So in order to find out the molarity of something, we have to know the moles and the volume. That's the only way we can do that. In this particular problem, we're given the volume of NaOH, nice, at the very beginning, but we don't know how many moles we have. So we need to find the moles of NaOH before we can find the molarity. Unfortunately, we can't calculate that directly. Now, the beauty about chemistry is, if you ever find in a chemical reaction, if you ever find the moles of one thing, any reactant or product, you will then be able to find the moles of anything else using the mole ratio. So I'm going to go ahead and find the moles of HCl and then calculate my moles of NaOH from there. So my moles of HCl will be equal to my molarity times volume. So that's going to be my 3.25 times my volume in liters, so 0.076. That comes out to be about 0.25. I'm going to make sure I label this well. Moles of HCl. Now, because this is a 1-to-1 ratio, so this is a 1-to-1, that means I also have about 0.25 moles of NaOH, which is great because I can then plug this value back into this molarity equation. So my molarity will be equal to my moles, which I just found are 0.25, over my volume, which is 0.1963. And if I plug those two things in, I will find that the molarity of my NaOH solution here is about 1.27 molar. And of course, because I'm a model student, I will be boxing that up. Here we go. Okay, and this is exactly the type of problem you guys did on your titration quiz right before spring break. So this is just a review. You should have been able to do this already, but I understand that we have a lot of rust we got to shake off. Okay, now as we move on to problems 3 and 4. So normally, like I said earlier today, that you would have had a lab today, but we need to shake some rust off. In this lab, I will tell you, hey, give me a certain amount of a chemical, and you'll be like, Mr. Pilcher, well, how much of each reactant do we need to start with? And I was like, I don't know, figure it out. Think of it this way. If I was like, Billy, I want 10 cheese sandwiches. They're like, okay. Well, do you have bread and cheese? And I'd be like, yes. Like, how much bread and cheese do I need? Like, I don't know, Billy. That's your problem. So here's what you would do. You would do two separate calculations, okay? So if I go ahead to my good old equation, my bread plus cheese equals sandwich. And we had this balance, right? We would realize that there are 2 slices of bread for every 1 slice of cheese to make 1 sandwich. So if your ultimate goal is to get 10 sandwiches, I'll put SW for sandwiches, you'd have to calculate how much bread you need, and then you'd have to calculate how much cheese you need. So you might do something like this. We're like, all right, so 10 sandwiches, that's in a 1-to-2 ratio with bread, so that means I need 20 slices of bread. Now you would have to do a second, totally separate calculation, and they may start the same way. So like, all right, 10 sandwiches, it's in a 1-to-1 ratio of cheese, so that means I need 10 slices of cheese. And so you worked backwards, starting with 10 sandwiches both times in 2 separate calculations, to find out how much of each ingredient you need. In a similar fashion, if we look at problem number 3, we're given an end goal. Hey, you need 6.5 grams of K2SO4, this guy right here. That's how much I want you to make. Available to you, you have a bottle of 1.5 molar KOH and a bottle of 0.8 molar H2SO4. And those are your only things you have. You're going to pour a certain amount of each one together to get those 6.5 grams. So what you're going to have to do is work backwards, just like we did with our cheese sandwiches here. Notice how we started with the sandwiches at the beginning of those calculations and moved to bread or to cheese. You'll have to do the same here, starting with your 6.5 grams of K2SO4. But, before we get too excited about that, there's something we're forgetting. We need to balance. We need to balance. So we got our K's, our O's, our H's, our S's. That's about all we have here. So if I'm starting this off, I got 1K, 2 over here. I've got 5 O's. I got 5 over here. I got 1 H here, a couple more here. So I got 3 H's on the left. I only got 2 on the right. I've got 1 S on both sides. Okay, so I got to fix the K's first. So if I plop a 2 right here, that'll give me 2 K's. Now some people are going to be tempted to double their O's. Like, okay, so 2 times 5 O's, I have 10 O's. Like, well, watch out for that. Actually, this 2, coefficient 2 in front of KOH, only doubles the O's in KOH. So I have 2 times 1 right here, so I have 2 O's, plus the original 4 from SO4. And so we only have 6 O's on the left. It'll also change our H's from not doubling the 3 to 6, because, again, there's only one of the H's in the KOH. There's a couple others with H2SO4. We now have 4 total H's on the left. And the S's remain the same. So now I got to fix my O's, my H's, and that's about it. Okay, well, why don't I go with something that has just O's and H's in it, the water over here. So maybe I'll try a 2 right here. It's the smallest number I can go with. That will bring my O's up to 6. So again, I have 4 here, and I got 2 times 1 here, so that'll give me another 2. And my H's, 2 times 2, that'll give me 4 H's. And, okay, here we go. Looks like we're all balanced. I'm going to erase this to get it out of the way. All right. Now, if you were to forget to balance here, you would be way off in your calculations for how much you actually need to get of each solution. Now, these 2 calculations will start exactly the same like we did with our 10 sandwiches. Calculations for KOH. All right, so I'm going to get to KOH here. I will start with my moles of K2SO4, my goal, if you will. Moles of K2SO4. So K2SO4, it's in grams, right? So that means it's a pure solid. So I'm going to go ahead and take those 6.5 grams, divide by the formula weight, which should be 174 when you add up 2 K's, an S, and 4 O's. If you plug that in, you'll find that you have 0.037 moles of K2SO4. Now, if I want to figure out how much KOH I need, KOH, so I'm going from K2SO4 to KOH, that is a 1 to 2 ratio. So I'm going to have to multiply it by 2. So I have 0.074 moles of KOH needed. Great. Now, back in the day, when we first learned Stoich, we set this equal to mass over formula weight, and we'd be good to go. But that's not what we're working with. We don't have a solid chunk of KOH that we're getting spoonfuls of onto a balance, but we have a solution. So we need to know how much we need to pour. Okay, well, we need that many moles. Moles of the solution will be equal to the molarity times the volume in liters. The molarity of KOH is given right here, so we can actually plug that in for our capital M here. So that's 1.5. Now, what do we have to do to get volume by itself on both sides? Well, if we divide both of these by 1.5 like this, this will cancel out. We'll have our volume by itself, which will lead us to calculate about 0.049 liters of KOH. Now, one thing you should note is that in lab, when you're actually doing this, all of your glassware in your drawer, they come in increments of milliliters, okay? So none of your glassware is big enough to be measured in liters. And so 0.049 liters, it's the correct answer, but it'll be a little bit confusing because your glassware is too small. So you should convert this back into milliliters when you write it down here. It says, notice it's asking for milliliters. So you need 49 milliliters, or about halfway of your graduated cylinder in your drawer of KOH. let's go ahead and calculate our cheese, as it were, our H2SO4. Well, our goal moles of K2SO4, this guy right here, we can just start with this. No need to calculate that same thing twice. So we're still shooting for 0.037 moles of K2SO4. Now the mole ratio this time, it was 1 to 2, but now if we're going from here just to here, that's a 1 to 1. So we also need 0.037 moles of H2SO4. Similarly to last time, we'll set this equal to the molarity times the volume. In this case, the molarity of H2SO4 is 0.8. I'll draw a little squiggly line to kind of keep these guys separate. Times the volume in liters. If we divide both sides by the 0.08, we'll find that we need 0.046 liters of the H2SO4. And of course, because my glassware isn't that big in my drawer, I'll convert this back into milliliters, as the problem asked me for. So I need 46 milliliters of H2SO4. In other words, to get 6.5 grams of K2SO4, I'm going to need to mix in 49 milliliters of KOH with 46 milliliters of the H2SO4. And if I do that, I should get the 6.5 grams of potassium sulfate, K2SO4, that Mr. Filter's asking me for. Now, what I want you to do is you absolutely should do problem number 4 without my help whatsoever. The answer key to this problem is below this video in this folder here on Schoology. But I want you guys to go ahead and do this on your own. Again, life starts with a balance equation. Watch out for that. In lab tomorrow on April the 7th, Wednesday, April the 7th, you'll be given a target mass for calcium carbonate as you walk in. And you'll have to calculate how much of a couple of different solutions you will need to get me the calcium carbonate that I want. On Thursday, we'll have a quiz that is one problem, just like questions 3 and 4 here. So the numbers will be different, the chemicals will be different, but that's what we're looking at. Think cheese sandwiches, people. Please email me if you have any questions or you need any help at all. I've got you. Okay? All right, have a good one. I'll see ya.